Welcome Algebra 1, this is section 4.3, Patterns and Nonlinear Functions. The essential question is, how are nonlinear functions different from linear functions? And let's begin. So what a nonlinear function is, it's a graph that doesn't form a line. So for example, these top three are linear functions because they're all lines. This is a line, this is a line. These dots form a line. A nonlinear function won't look like a line. This is a parabola shape. This is the graph of a cubed function. And this forms a v. It's an absolute value function. So these aren't lines. So let's do this. We're going to graph this function, and you're going to tell me if it's linear or not linear. So this is a function of pizza area. So the radius of a pizza versus the area of a pizza. So I want to plot this. I'm going to put radius, r is going to be my x-axis. So I'm going to label this radius r. And then on the y-axis, we're going to have area. So I'm going to put area over here. And area A. So plotting the first point. Now the first thing before we plot, and we'll practice more of this in class, you have to figure out the scale of your x and y. So on the x-axis we're going 2, 4, 6, 8, 10. So I can go up 2, 4, 6, 8, 10. How about this? I'm going to go up 2 for every block. So 2, 4, 6, 8, 10. So I'm going to choose to go up 2 every unit. Now on the y-axis, this goes up to from 12 to 314. So I can't just count up 1 every time because I'm going to go way off my page. I'm looking at that range right there, and look how many units I have, about 10 right here. I'm going to say, let's make every block worth 50 inches squared, okay? So we're going to count up 50, 100, 150, 200, 250, and 300. So when we plot this, I know we're not going to be able to exactly get 12.57, but we'll get a pretty close estimate. So for the first point, 2 and 12.5, it's going to be 2's right here, and 12.5, I'm going to guess it's about right here. That's pretty close. Next one, 4 and 50, 50 and 27 hundredths, it's just above that. It's basically on that dot. That's close enough. For 6, it's 113. 113 is going to be a little bit above, about right there. And 8 and 210. So 210 will be about right, or 201.6, so it'll be right barely above that line. And at 10 inches radius, we have 314. 314 will be about a little bit above. Should be about like a quarter of the way between units. So we've plotted these points, and the question is, does this form a line? Well, if I graph, I'm trying to draw a straight line. I got a tool that lets me do a straight line. If I started at 2 and went up to that point, I know I didn't graph 100% perfectly, but you can kind of see that, you know, even if I'm off a little bit because I'm just kind of estimating some of those dots, we're not a straight line at all. The graph actually kind of has this curved shape right here, and this is actually exponential, I think. So, or it's actually this would actually form a parabola if we kept going. So this function is nonlinear. Nonlinear. So we say nonlinear because it does not form a line with those points. It's forming a curve. Let's try a different one. So this is the cost of sauce. The weight of the sauce in ounces and the cost C. So we're going to put the weight on this side in ounces. Call that W. And the cost on this side, it's going to be in dollars. We'll call that C. So again, 2, 4, 6, 8. I'm going to plot this. I'm going to call this 2, 4, 6, 8, 10. And on the y-axis, well, it's going from 80 cents to $4. So I got some options here. I think I'm going to go up 50 cents each time. That should be good. So 0.5, 1.00, $1.50, $2, $2.50, got $3, got $3.50, got $4. So you want to label your axes, and $4.50. So now that I got those labeled, let's plot the first point. 2 and 80 cents. 80 cents is going to be about right here. 4 and $1.60, that's going to be about right here. And 6 and $2.40 be about right here. And 8 and $3.20 should be about right here. And 10 and $4 even will be exactly on the line right there. So the question is, do these form a line? Well, if I graph these and draw a line, look at that. That is a pretty good fit. And you know what? That is definitely linear. All right, try a different graph. So we're going to graph this pattern here. So you see a pattern with these blocks. So the first block, and we're going to count how many blocks are on the edge. So this is at 1, 2, 3, 4, 5. So we're going to create this table to plot. So 1, 2, 3, 4, 5. Now we're going to plot the number of blocks on the edge versus the total blocks. So in the first case, how many blocks do I have? 1. In the second case, it's growing, right? Each edge is growing. And you can count. There's going to be 4, 1, 2, 3, 4, and then in the back there's going to be 1, 2, 3, 4, so that's 8. Now the next block, when we have an edge of 3. So you're looking at this, and there's going to be 9 in the front, 9 blocks in the front. Well, the next row is going to, since it's 3 deep, it's going to have another 9, and they're going to be in the back, it's going to be another 9. That's going to total up to 27. And the nice thing as you start seeing these patterns, we're creating cubes here. And if you see this pattern, the first one's just a 1 times 1 times 1. The next one's 2 times 2 times 2. The third one, we grow the length, width, and height by 3. It's 3 times 3 times 3, and that's 27. Well, the next one will be 4 times 4 times 4, and what's that? That's going to be 64. And the last one's going to be 5 times 5 times 5. And then what that's going to be is 125. So as you start counting these, sometimes you'll recognize a pattern happening. So let's graph these. So we're going to call this the blocks on edge. It's going to be my independent variable, and the total blocks is going to be my dependent. And okay, so I'm counting up 1, 2, 3, 4, 5. So I'll count 1, 2, 3, 4, and 5. And then, well, what are we going to do on the other axis? I mean, it's going from 1 to 125, so I'll probably have to go up. You make a call. Maybe it's 125 every time, or go up 25 every time. That might work. Or we can go up 20 every time. I'm going to choose 20. You just have to pick a number that you think makes sense. Oops, 60, 80, 100. It's something that's going to fit. Not 125, 120, and this is going to be 140. Okay, so let's plot those points. So at 1, our number of blocks is going to be 1. That's going to be like right here. And at 2, our number of blocks is going to be 8. That's going to be about right here. At 3, it's going to be 27, which is going to be not quite in the middle, a little under that, so right there. At 4, it's going to be 64, which is going to be right above 60. And at 5, we got 125, which should be way up here. So if I graph this pattern, it looks like this. And you can kind of see, look at this. This is definitely going to be nonlinear. Because if you try to draw a line between all those, going from this point to this point, you see it's definitely curved. So that's not. I'm going to write nonlinear. And this is the graph of that pattern. All right, why don't you try this out? So pause the video. All right, so I want to graph this pattern. This is a little different here. It's kind of maybe a little bit more difficult. So number of cuts n. This is going to be on the x-axis. So I'm going to call this number of cuts n. And on the y-axis, we're going to say fraction remaining. So you're cutting a paper in half every time. And how much paper is left? Well, let's count this up. So it's going to be 1, 2, 3, 4. So every cut. And, well, look how this is growing. This is starting at 1/2. And then you get to 1/4 and 1/8 and 1/16. It's actually getting smaller. But they're all fractions. They're fractions that are less than 1/2, but it's between 1/2 and 0. So I don't want to count up 1, 2, 3, 4 every time. That's going to make my graph really small and hard to see. I want to spread this out. So let's say I can say that this I can count up. Let's count up by 1/4 every time. I can choose 1/4. 1/4. This will be 2/4 or 1/2, and this will be 3/4, and let's say 4/4 or 1. Let's say if I graphed it this way first. Okay, so at 1 it's going to be 1/2, which is right here. At 2 it's going to be 1/4, which is right here. At 3 it's going to be 1/8, which is half of 1/4, so about right there. And 4 is going to be 1/16, so it's going to be half of 1/8. It's going to be about right here. So there's the graph of the function. Is this linear or nonlinear? Now, if I looked at this, I draw my line, it's looking like I got a little bit of a curve here. So that's actually going to be nonlinear. I can write that. Nonlinear. Alright. Now, that graph did seem kind of smashed in there. If instead if I grew by 1/4, if I grew by like 1/8 every time, the graph would be much spread out a lot better and be easier to see if it was nonlinear. Alright, pause the video, try this one. Okay, so graphing the pattern here. And the nice thing is the first few I've figured out. So how many branches do you have? The number figure and new branches. So for the first figure, it's the red ones, 3 new branches. So the second figure, each of the original 3 branches grows 3 more branches, so it'll be 9. The next one's 27, because those 3 branches, 3, 3, 3, 3, 3, all multiplying by 27. So let's go, So what are my next pattern going to be? Well, looking at what's going on here with this pattern, every one of the previous new branches grows 3 new branches. So basically, we take every one of the last branches and multiply by 3. So I went 3 times 3 was 9, so you did it times 3. 9 times 3 was 27. So for the fourth figure, it'd be times another 3, which is going to be 81. And for the fifth figure, it's going to be times another 3, which is going to be 243. So let's graph that. So this is going to be the figure on the x-axis, and then we're going to say branches on the y. So what's figure? Well, we're counting up by 1, 2, 3, 4, 5. So I'll go 1, 2, 3, 4, 5. And new branches. Well, the lowest is 3 and the highest is 243. So I got to count. I got to go up pretty fast here. So I'm going to go up by, let's say, 50 every time. 50, 100, 150. You know what? Let's not even do 50. Let's do 25. That might be a little better. So 25, 50, 75, 100, 125. Let's get this out of the way. 150, 175, 200, 225, and this is going to be 250. Just enough. So let's plot those points. So at 1 I get a 3, which is going to be way down here. At 2 I get 9, which is a little above that. At 3 it's 27, so right above the 29 mark. At 4 it's 81, so it'll be a little above the 75. And at 5 it's 243, which grows up to way up here. So is this linear? Well, clearly, look, I bet you could eyeball that and tell you it's not. So yeah, that's not linear at all. So I'm going to say nonlinear. And that makes sense because this chapter was about nonlinear patterns. But there's your pattern. That's it.